Okay, we're going to be solving absolute value inequalities. There's two things that we have to do. It's not that much of a change. You just have to remember to do one or two things with the inequalities. It won't be that bad. We're going to start with graphing them, how to graph them on a number line, because that's going to help you find your answers in interval notation. So for this first problem, it says the absolute value of x is greater than 5. Now, absolute value is your distance from 0. Okay, traditionally it shifts left and right, but it's your distance from 0. So for this problem right here, it's saying, well, what numbers are greater than or equal to 5 spaces from 0? So, well, I know 5 is exactly 5 spaces from 0. I know 6 is more than 5 spaces from 0. I know 7 is. I know 8 is. I know 9, 10, 11. So it would keep going. And so I'm going to have a little circle around 5, and it's going to keep going to the right, because all of this represents, everything under this line represents all of the numbers that are greater than 5 spaces from 0. On the other side, I also know that there are numbers that are 5 spaces from 0 on the left side. Okay, and that's where we talk about the negative is to the left, the positive is to the right. So for this, I know that negative 5 is 5 spaces away. And then negative 6 is, negative 7 is, negative 8 is, negative 9 is, so on and so forth. So I have an arrow going to the left. Same thing, this arrow is just, it keeps going to the left, and anytime it keeps going, it's going to negative infinity. It just tells you that that's always going to be going to the left. And then on the right, this goes to positive infinity. All right, anything underneath this, remember, represents a number that would be a solution to this. So if I put, let's say, negative 8, well, the absolute value of negative 8, that's greater than or equal to 5. Okay, so is 8 greater than or equal to 5? Absolutely, that actually checks out. Okay, so for this, that's what that means. Anything underneath here is going to be a solution to the problem. So we put this in interval notation. My graph is in 2 parts, so I write it in 2 parts. So I know I have from negative infinity to negative 5, and my other part is from 5 to infinity. Things that I remember, this is going to be open parentheses because it's infinity. You can never reach infinity. Here, because this is or equal to, I know that my brackets are going to be closed, and I'm going to put what's called the or symbol in between. Okay, and so that's what I wasn't really picky about that with the last unit, but for this unit, we are getting to more specific things, so make sure that you put that or symbol. So this is in 2 parts. Here's the second case. So we have greater than or equal to. Now we have less than or equal to, and so we're gonna look and see what that looks like. So now we're looking for all the values that are less than 8 spaces away from 0. So here's my 0. I know 1 is less than 8 spaces, 2 is, 3 is, 4 is, 5 is, 6 is, 7 is, 8 is less than or equal to 8 spaces, but 9 isn't. So I actually stop right here at 8. Okay, and then to the left, I'm going to do the same thing. So negative 1 is 1 space from 0, 2 is 2 spaces, that's less than 8, 3 is less than 8 spaces, negative 4 is less than 8 spaces. Keep going all the way to negative 8, and then it stops there, because negative 9 is more than 8 spaces away from 0. So what I do here is all of my answers are between these values. I know it's or equal to, so I know it's going to be filled in. Okay, and so when we put our brackets in, it's going to be from negative 8 to 8, and I'm going to put closed brackets in because this is or equal to. Okay, so moving on to solving equations. So we have the graph down. Solving equations, you isolate the absolute value. Things that you have to remember: switch the inequality symbol if you multiply, divide each side by a negative number, create 2 inequalities, keep each side of the inequality, the symbol the same. So for the first, you're going to do the same thing that we did before. The only thing that you have to remember for when you solve the second is it's the same thing as as when we were solving equations, except you're going to switch the inequality symbol. It's going to actually switch directions on you. Okay. Then you just go through, solve both inequalities, graph your solution, write your answer. So the other new thing is, of course, graphing. So we're going to start with a simple one, this one right here. And so we have either x is less than positive 7 or x's, and we're going to do the keep switch switch. Okay, so I keep what's in my absolute value, I switch the inequality symbol, and I switch the number. So instead of positive 7, this is negative 7. There's really not much solving to do with this, so now I'm ready to graph my solutions. So the first thing, x is less than 7. So I go to 7, I don't fill in my circle because it's just less than, and I know I'm going to have an arrow if it's less than that goes to the left. This one says x is greater than negative 7, so I go to negative 7, and I know it's greater than, so it's going to actually be going to the right. And so what I'm going to have is I'm going to have one of these intervals right here. Okay, now that actually makes sense because up here at case 2, we had that less than or equal to 8, and we know if we have an absolute value and it's less than, it's going to be this right here where it's just between two values. If it's greater than, you have the absolute value by itself, and it's greater than, it's going to have two separate values, and we'll continue to talk about that. So let's move on to interval notation. Sorry. So interval notation, I know all my values go from negative 7 to 7. It's going to be open parentheses because it's not or equal to. So our next problem right here. So first thing I always do is I get my absolute value by itself. So for this, I'm going to divide each side by 3 first before I solve. So 2x plus 5 is greater than or equal to 3. Okay, so now I'm ready to solve this twice. So I'm going to solve this 2x plus 5 is greater than or equal to 3. Then I'm going to have, I'm going to keep the 2x plus 5, that doesn't change, but I'm going to switch this around. So instead of greater than or equal to, it's going to be less than or equal to, instead of positive 3, it's going to be negative 3. And that's just because we're thinking about solutions to the right and solutions to the left. That's why you switch it, because if we're going to the left, it's going to go to less than. It's going to be the opposite, or greater than, just depending on what we're talking about. So I go through and I solve each of these like normal. I subtract 5, 2x is greater than or equal to negative 2. I divide by 2, divide by 2. Now, some of you may remember when you solved inequalities so long ago that when you divide by a negative or multiply by a negative, you're going to have to switch the symbol. In this case, because I'm dividing by a positive 2, I don't have to worry about switching my inequality symbol. And we'll talk about that in just a bit. For here, I subtract 5, 2x is less than or equal to negative 8. I divide by a positive 2, so x is less than or equal to negative 4. Okay, I graph my solutions. So I graph my solutions in this case. So x is greater than or equal to negative 1. So I have my negative 1 here. I know it's going to be greater than or equal to, so it's going to go to the left. X is less than or equal to, I put negative 1 in the wrong space. I'm sorry about that, guys. Negative 1, okay, I'm going to fill that in because it's or equal to, and I know it's going to go to the right. Negative 4, so x could also be less than negative 4. It's going to go to the right. And we said that we were looking for greater than that number of spaces, and we know greater than goes in opposite directions. My interval notation, of course, if I have an arrow to the left, it's going to be negative infinity. If I have an arrow to the right, it's going to be positive infinity. So my notation is going to be from negative infinity to negative 4. And then I'm going to go from negative 1 to positive infinity. And I know I'm going to have an open parentheses here because that's infinity. I'm going to have closed parentheses around those guys, and I'm going to put the or symbol in. And I'm sorry I didn't put enough space around those ones. So, next one. Okay, we have to first get our absolute values by itself. So I add 16 to each side. Because remember, if it's not right next to the absolute value, that's addition or subtraction. So I'm going to get rid of my addition or subtraction. Do not forget to bring down this negative 3. Okay, don't forget to bring down that negative because that negative is with the 3. So negative 49 plus 16, it's going to be less than negative 33. Now here is the switch. So I'm going to be dividing each side by, negative 3. Okay, this is where the magic happens. So when you are dividing by a negative, the first thing you need to do by a negative is you need to make sure that you have that inequality symbol switched. And so this ends up being the absolute value of 2x minus 5 is greater than positive 11. So again, make sure that you put those, switch your inequality symbol when you divide or multiply by a negative. So by a negative. All right, so be careful with that. All right, now we're ready to actually solve this twice. So this is going to be 2x minus 5 is greater than 11. And then you have 2x minus 5. But I switch. This is going to be less than negative 11. Keep switch, switch. Okay. So I add 5 to each side. 2x is greater than 16. Divide by 2, divide by 2. X is greater than 8. Plus 5, plus 5. 2x is less than negative 6. I'm dividing by a positive 2, so I don't have to worry about switching it. 2x is, or sorry, 2x, not 2x, a little overzealous. 2, or x is less than negative 3. So I go through, I graph, so x is greater than 8. So it's going to be, I'm going to put an open circle around 8, and it's going to go to the right. And then I put an open circle around negative 3, and that one is going to be going to the left because that's less than. And of course, when we have, when we get down to the inequality, this is greater than, so yeah, it's going to look like that. My interval notation, it's going to go from, well, it goes to the left, so I know I'm going to have my negative infinity, stops at negative 3, and then it starts again, my graph starts again at 8 and goes to positive infinity. Open parentheses, open parentheses, open parentheses, open parentheses, because it's not or equal to, and I put the or symbol. Okay, this is the last regular example that I have for this. So again, go through the same thing, subtract 10, subtract 10. So I have negative 3 halves times the absolute value of 3x minus 9 is greater than or equal to negative 9. And all I did was subtract 10. Okay, so what I'm going to do is I want to get rid of this fraction, so I'm going to multiply each side by a positive 2. I'm multiplying by a positive, so I don't have to worry about switching the inequality symbol. So I have negative 3 times 3x minus 9 is greater than or equal to negative 18. Now, here's where the magic happens. Because I have this negative 3, when I divide by negative 3, that's where I have to have the magic of switching the inequality symbol. Okay, when I divide or multiply by a negative. So this ends up being just the 3x minus 9 absolute value is less than or equal to 6. Okay, now with this right here, I know that if it's less than, it's going to be it's going to just have one interval. That's my prediction. Because that's what the pattern has been. This is 3x minus 9 is less than or equal to 6, or 3x minus 9 is greater than or equal to negative 6. Remember, keep, change, change. So add 9, 3x is less than or equal to 15, divide by 3, x is less than or equal to 5. Add 9, 3x is greater than or equal to 3, divide by 3, x is greater than or equal to 1. And I go through and graph. So we have x is less than or equal to 5, so I put a circle around 5. know what I just did. Okay, sorry about that. Technical difficulties. This never happened with maybe just where I'm clicked. I don't know. This is not what I need in life. Home. What did I do? Oh, okay. I don't know what I did, so sorry about that. Technical difficulties. So I have to go through it and graph. So it's going to be x is less than 5, so I put a circle around 5, and I know it's going to go to the left. I have a 1 here, and it's greater than. I know it's or equal to, so I'm going to fill this in. So I know my graph, I read from my graph, goes from 1 to 5, and I put closed parentheses around both because it's or equal to. Okay. Last thing I just want to talk about was special cases. So I just want to show you what happens, and this is one of the things that you need to be aware of when you're solving, because it's going to stop. And we have talked about this before. So I'm going to look at this one right here. So I'm going to add 6 to each side of this. So I have -3 absolute value. So I'm going to just solve this like normal is greater than 3. I divide by -3. I divide by -3. What I need to remember is that when you divide by a negative, this switches, my inequality symbol switches. And that's just to make sure that the inequality remains equal. So I have the absolute value of x plus 2 is less than -1. Now you stop there. Anytime you have a negative, okay, on one side an absolute value, and on the other side, it's going to be one of two answers. It's either going to be no solutions or infinite solutions. Now, when we had equations and you ended up with this would be no solutions. In this case, sometimes it's hard to tell, but I know that an absolute value, that's always going to be a positive number. So what I do is I write, if I forget, which I don't, but if I said a positive number is less than -1, can any positive number be less than -1? No. Okay, so for this here, then this is going to be no solutions because because there's nothing I could put in for x that would actually work. And so for this would just be no solutions. You wouldn't put anything in the graph. So when the absolute value is less than or equal to a negative, okay, so if you have your absolute value and it's less than a negative, or you have your absolute value and it's less than or equal to a negative, that's going to be no solutions. Okay, so that's less than or equal to. Greater than or equal to is going to be a little bit different. So I'm going to go through the same process, add 3, 4 times the absolute value of x plus 2 is greater than or equal to -12. I'm dividing by a +4, so I don't have to worry about switching my inequality symbol. But so I have my x plus 2 is greater than or equal to -3. I stop here. Okay, whenever I have this negative here, this is an issue. Okay, so now you have to figure out, is this no solutions, or, well, let me just put the word positive in. Positive number. So I'm going to replace this absolute value because this is going to be a positive number. No matter what number I put in for x, I could put -500 in for x. That'd be -500 plus 2, which is -498, which would be the absolute value that would be greater than 1. So is a positive number going to be greater than or equal to -3? Yes, any number, any positive number. This is actually always true. So if it's always true, what you're going to do is your graph is just going to have an arrow to the left, an arrow to the right, and your answer is going to be all real numbers Or if it asks you to put it in interval notation, well, my answers are going to be from negative infinity to positive infinity, because all real numbers in negative infinity and positive infinity mean the same thing. So when the absolute value is greater than or equal to a number, then sorry, this shouldn't be here, then actually this should be greater than or equal to a negative number, then it's going to be all real numbers. So we have our absolute value. If it's greater than a negative, we have our absolute value greater than or equal to a negative. This is going to be all real numbers, or from negative infinity to positive infinity. So that's how you do inequalities. Just a couple things to remember, but hopefully you'll have your notes and everything next to you soon.